साधूला तरी पाठवते एस्टिमेट काय आता एकच खाडे साहेब बोलतात ते क्लिअर नव्हतं शिफ्टिंग ते मला चेक करून द्या तुम्ही इकडं क्वांटिटी रेट काहीतरी वेगळं वेगळं येतं
बेनके साहेब बेनके साहेब हो बेनके साहेब तुमचा आवाज आला तुमचा आवाज आला
आले का मॅडम
पहले पासून hello
yes madam
just wait sir um, okay sorry participants for the inconvenience. I welcome all participants for third day of first session of the STDP on environment engineering for global sustainability organized by Saraswati Institute of Technology. It's my pleasure to introduce our honorable speaker, Mr. Swapnil Desai, sir. Mr. Swapnil Desai, sir, is a mechanical engineer at Navi Mumbai Municipal Corporation, Maharashtra, and has 15 plus years of experience in water and wastewater sector. He is handling sewage treatment plants for entire city. He has done his MTech in energy technology and pursuing PhD in environmental engineering. He is a member of some reputed engineering bodies and publications such as Institution of Engineers India, Institute for Engineering Research and Publication, senior member of the Indian Society of Mechanical Engineers, ISRP Malaysia, International Solar Engineering Society Germany, and Sustainable Sanitation Alliance India chapter. He has got National Education Brilliance Award from Icon Foundation in association with Hypage Media Jaipur, Research Excellence Award from INSC Bangalore, Innovative Researcher and Dedicated Excellent Professional Achievement Award from CIESRP Chennai. He has also completed various courses in area of wastewater treatment and renewable energy from CSC New Delhi, EA Water New Delhi, and Acharya Silicon Limited Chennai, Water Supply Engineering and Wastewater Treatment and Recycling at IIT Kharagpur. His research areas are water, wastewater management, renewable energy system, environmental pollution, and waste management. He has published various papers in the journal and conference of national and international repute. Now, I invite our today's guest. Please, sir, hand over this session.
okay good morning everyone. First of all, thank you very much for inviting me as a speaker for 1 week MSBTE approved training program on environmental engineering and for global city. Thank you very much for Saraswati Institute of Technology, Khargar, Navi Mumbai. So, for the, am I audible to everyone?
Yes, sir. Yes, sir.
Okay. So, for the perspective in environmental engineering, the wastewater treatment is a very key factor. So, we will study how the Navi Mumbai is done, how Navi Mumbai tackle the wastewater which is generated within the city. So, we will study the case study at Navi Mumbai. Navi Mumbai has one of the cleanest city in India, and from last 3 to 4 years, Navi Mumbai has got the national awards, and under such a survey has got the one of the cleanest city from last 3 years. So the city profile has NMS has a population of around 12 lakhs, and its existing population around 14 lakhs. The floating population around 2.5 lakhs. The total area of Navi Mumbai is around 108 square kilometer. The city has supplied around 420 million liters per day of water. Total sewage treated and generated is around 215 MLD. So we have a total sewer line length of around 405 kilometers. The total distribution, that is the collection system for entire sewage generated within the city. And through this sewer line, we have a number of pumping stations. With the help of that pumping station, we pump the sewage generated within the city, and it is transferred to the wastewater treatment plant for the treatment perspective. So before the initiative, NMNC has a conventional 7 number of sewage treatment plant, which is based on generally irrigated lagoon system. Most of the treatment units are in under deteriorated conditions, which are resulting in the partial treatment of the sewage. And so, because of the variation in the flow, like in summer and in monsoon season, there is a variation of the flow. So, the existing sewage treatment plant does not cope up with the variation in the flow. So, this led to the leaking or overloading of the pipes, or an inefficient treatment plant allowed it to untreated the sewage, which is directly into environmental or routine basis. So, overall, the complete disorder towards the sanitary system and hygiene in the vicinity. So, while considering that NMC had adopted some strategy for the sewage treatment, which existingly evaluate the existing sewage network, that is the collection and the conveyance system, and the treatment facility within the city. Also, we identify the identical sewage treatment facility and sewer required to handle the raw sewage generated within the city. We also aware of the different sewage treatment technologies available in the market. Like there are different type of technologies available in the market today. Like sequential batch reactor technology there, MBBR is there, MBR is there also. So also there are different uh, uh, ultrafiltration, reverse osmosis, nanofiltration technologies are available. So we expand the enhance the existing sewage collection, convenience and treatment facility, which will cater the growing population of Navi Mumbai. We have done the master plan and adoption of the best practices for the operation maintenance also. Also, the treatment facility our is based on the conventional technology, which is basically a aerated lagoon system and absorption dish system, which do not generate the treated as norms laid down by the State Pollution Control Board. So, NMS has decided to go for some advanced treatment technologies in the field of the wastewater treatment. These advanced treatment technologies are basically the modification of traditional treatment by making the changes in the process, or and by introducing or within the automation work. So this technology named as the CTEC technology, that is sequential batch reactor technology. This CTEC based advanced sequential batch technology is nothing but it's a activity sludge treatment plant where most of the sewage treated in the batch instead of that is continuous process. It has its operation is mostly controlled by the programmable logic controller panels, and the footprint area of the CTP is less than that of the conventional technology. So our aim is to adopt the modern technology in the area of the sewage management, recycle and reuse of wastewater to every possible extent, like in garden purpose, in washing of the cars, and other non-portable purposes. We provide a 100% sewage network and the sewage treatment facility within the city and make the same sustainable sewage system. We expand and then enhance in the existing sewage collection system, convenience and treatment facility. that will cater the population of the Navi Mumbai. Also provide the safe, hygienic, and clean environment, and green environment to the residents of the Navi Mumbai. So these are the basic infrastructure of the sewage management within the city. NAMC has 6 number of sewage treatment plant. One is at 100 ml capacity at Nerul and Washi, another 80 ml capacity at Airoli, 87.5 ml capacity at Kopar Kharne, 37.5 ml capacity at Sanpada, and 19 ml capacity of Belapur. Also, from the Circo, there is a 130 ml sewage treatment plant, which is constructed by the Circo, and it is handed over to NAMC in the year of 2017. So we have total 7 number of sewage treatment plant, which having a total capacity of 450 mld. We also have a 20 number of sewage pumping station that can handle the or that can receive the raw sewage generated within the city and transfer this raw sewage to the this existing this 7 number of sewage treatment plant. The total sewage pumping capacity is around 12 million liters per day, and total length of the sewer line is around 494 square kilometer. At present, around 250 mld raw sewage has been treated at our 7 number sewage treatment plant. So these are the details of sewage pumping station. Basically, our old plant is based on the conventional technology, which has around 176 mld capacity, and we upgrade this plant based on the modern technology, which is known as the SBR, sequential batch reactor technology. So we upgrade the treatment capacity from 176 mld to 454 mld. Also, the area requirement for this modern technology-based STPs is around 50% less than that of the conventional technology. So this is our sewage treatment plant, which is located at different location at Navi Mumbai. One is at Belapur, one is at Nerul 15, one is at Kopar Kharne, one is at Bela Airoli, one is at Sanpada, and one is at Washi. This is a typical process diagram for this sequential batch reactor technology. Firstly, raw sewage from the pump houses and the pumping station is collected at the sewage treatment plant, where within the sewage treatment plant also there is a raw collection tank, which is known as the pump houses. The function of this pump house is to lift the raw sewage to the primary treatment. In the primary treatment, we have installed the different type of screens, that is mechanical bar screen that can remove the floating particles up to 12 mm, and then another there is a fine screen that will remove the floating particles up to 6 mm. Then this raw sewage transferred to the grid chamber, where grid particles removed, like sand particles. Then this primary treated raw sewage is transferred to the sequential batch reactor basins. We have for each plant we have around 6 to 4 basins where different processes are carried out. Then we can see one by one what will the different processes. Then after sequential batch reactor basin, the semi-treated sewage is then going to the chlorination system, where we have a chlorine system to disinfect the various bacteria and viruses. And finally, the treated water is collected at the collection tank. Also, in a sequential batch reactor basin, there is a sludge generated within that basin. We can lift this basin with the help of different pumps, that is reverse activated sludge pump and surplus activated sludge pump, and that can transfer to the centrifuge machines. This centrifuge machine basically remove the water contents of that sludge, and this sludge is act as a manure for gardening purposes. We use this sludge for our horticulture purpose. So we can see one by one the what will the different units in sewage treatment plants. First is receiving chamber, as we discussed. Raw sewage for different terminal manholes is discharged into this receiving chamber. Basic function of this receiving chamber is to distribute the flow for the process unit. Again, there is a mechanical core screen that can remove the floating material up to 20 mm particles. Again, there is a manual screen. Then after screening, raw sewage is into the wet bed for pumping station. We have a 7 number of pumps which having a capacity of 175 HP. This pump is discharge the sewage to the fine skin for removing the 6 mm particles. This is basically a mechanical fine skin which will use to remove the particles up to 6 mm. Then mechanical grid chamber. After screening, this wastewater mechanically clean. There are basically this is a radiator tank where the wastewater is provided with the constant conditions so as to settle around the grid particles above 1.50 micrometer. And this clapper mechanism is used to remove the grit, and it contains generally inerts and organics. We have also organic pumps too, which is provided within the classifier. This is basically a grid chamber mechanism. So again, as we discussed, after primary treatment, which includes screening of 20 mm particles, then 6 mm particles, and also remove the grid. This is basically a primary treatment. This primary treatment is any kind of technology. If you adopt it, there is a primary treatment that can remove the floating materials and the grid particles. Then there is a basins which generally biological process where we have a four cycles within that basin. First is aeration, second is first is filling, second is aeration, third is settling, and for last one is decanting. So it has a 3-hour cycle. We can see what happens in that basin. So CTEC component, it has a biological selector zone, it has a diffusers for which will provide the oxygen for bacteria within that reactor. For the to provide the oxygen, we have an air compressor within the system. Also, the decanter assembly in stainless steel that can handle treated water, and it is transferred to the CTEC basin for transfer the chlorination system for disinfection of the bacteria and the viruses. So this is a typically we can see the what is the actual SBR CTEC. So SBR is a aerobic biological process. It has a suspended growth process similar to that of activated stress process. The waste is degraded by a biomass, that is bacteria and other living organism. It has a batch process, whereas aeration, settling, filtration that can handle happens in single tank. Typically, SBR consists of 4 cycles, as we discussed. First is filling, second is aeration or to death, third is settling, and last one is decanting. So this is a typically 4 cycles within that basin. Firstly, for 30 minutes, raw sewage is entered to the basin. Then 60 minutes is for aeration. Then again 30 minutes is for settling, and again 60 minutes is for decanting. So fill and aeration, as we see in the picture. First is the aeration. Picture is the aeration mode, where we have a number of diffuser system installed within that aeration basin. The basic function of this aeration is to grow the bacteria within the basin that can decompose the organic matter. And after settling down the organic matter at the bottom of the basin, the treated water, as we see in the last picture. So this is basically a stainless steel decanter that can float onto that of treated water, and that this treated water and transfer it to the chlorination system for a disinfection of bacteria and viruses. This is our chlorine contact tank, where we are given the 2 ppm dose for treated water that can remove the bacteria and viruses. This is the sludge handling unit, which can remove the water contents within that of sludge. So this is our treated quality before treatment and after treatment. This is the quality parameter, as we have in-house laboratory to test the different parameters like biological oxygen demand, chemical oxygen demand, ammonia nitrogen, total phosphorus, fecal coliform, pH, and oil and grease. So this is our outer parameter. We have BOD less than 5, COD less than 100, total suspension salt is less than 10, nitrite nitrogen also less than 10. So this is the performance and the sustainability of treated water from last around 14 years. So as per the Central Pollution Control Board, the BOD limit is around 10, but we have achieved the BOD less than 5. Also the COD less than COD limit is less than 50. So we achieve the COD around 20 to 30. Total fecal coliform also we have 12 to 13 mpn count, and the pH value is within 6 to 9. So for the outcome, the cost of that our portable water treatment and conveyance up to the city is around 2.1 rupees per meter cube. Operation maintenance cost of the STP is around 1.6 rupees per meter cube. We have the part of the potable which is supplied to the commercial, institutional, industrial consumer for non-potable purpose. So the STP can design to cater the need of the sewage treatment till 2031. Also, the structure and equipment of material construction are also selected for longer life. STP are also treated to treat the sewage to the highest level. Thus, the pollution load on the nearby creek is reduced. So we have a consistency of quality in the quality parameters of treated sewage from last 12 years. Also, the capacity of the STP is designed in such a way that can handle the situation in rainwater flooding also. Also, we save the land 50% less as compared to our conventional treatment plant. Around 215 ml treated sewage water demand is to be generated for the industry. So it has a large potential for the revenue. Dry soil also we use as a manure for our horticulture belt in an MC area. So the bad odor from problem like in conventional treatment plant. So this problem is eliminated with the help of these modern STPs. So the overall environmental condition has been improved. So in the area of recycling and reclamation of treated water, we put the options for what will the technologies available for tertiary treatment. So we study the STP processor for reuse. We have a gravity sand filter, fiber disc filter, submerged MBR, that is the membranous bioreactor, and the RO reverse osmosis system. For the initiative for recycling and reuse of this treated water for non-potable purpose. These are some inlet and outlet parameters. In order to, if you go for the, if you reuse the treated water for different purposes, like for gardening, so Central Pollution Health and Environmental Engineering Organization, it is autonomous body to MOEF, is laid down the quality parameters for different different characteristics like BOD, COD, TSS, fecal coliform, total nitrogen, TDS, etc. So, in order to carry out the recycling and reuse of this treated water, we have a number of meetings and discussion with the IIT, MSBTE expert from the area and chief engineer from the CIRCO and other experts from Maharashtra Jeevan Pradhikaran and consultant of NMC. So, as outcome of discussion and site visit, to meet the outer parameters that is prescribed by the CPHEO manual and that is the requirement of MIDC, the ultrafiltration process is finalized. So this is the tertiary treatment of treated sewage where ultrafiltration modules are there which can handle the bacteria and viruses, and also the total suspended solid that can generate the industrial get water for their industrial purposes. So uh, we have installed the tertiary treatment plant. One is at Cooperkhelde and one is at iRoad STP. Our Cooperkhelde plant is commissioning, and we have made agreement between NMMC and MRDC to sell the treated water for around 15 rupees per meter cube. So in that process, typically we have a second treatment plant. In the outlet, final outlet of this second treatment plant is then transferred to the tertiary treatment plant, where firstly there is a sand filter. Again, after the sand filter, there is a disk filter that can remove the suspended solid up to or less than 3. Again, this treated water then transferred to the ultrafiltration module, where all the bacteria and viruses are removed. And then again, after that, we have installed the UV system to dissipate the pathogenic bacteria. So this is the network for treated water that can be sold to the Maharashtra Industrial Development Corporations. The operation maintenance cost of the tertiary project is around 3.80 rupees per meter cube, and for the tertiary it has a 2.44 meter cube. So the production cost of this treated water is around 16.23 rupees per meter cube, and our water sale rate is around 18.15 meter cube. So total expenditure for the NMSC for next 15 years is around 376 crore, and we have our projection for the revenue is for the next 15 years is around 494 crore. So we have a 40 ml of tertiary project under Amrut mission. It has a dual media filter with UF and UV system. This tertiary project to supply the treated wastewater to desired quality within the state-of-art facility from 2-stage plant to various industrial estate for a non-domestic purpose. Also, we have a 5 ml tertiary treatment project with fiber disc filter and UV disc filter system. That treated water are used for the green belt developed within the road and 31 gardens in the city. So this will reduce the infrastructure for the drinking water. So almost 30% of treated water, that is around, we treat the 250 mld raw sewage, and out of that around 65 mld treated water is reused for different purposes within the city, like in garden or washing of solid waste vehicles, compactors, city transport bus, sprinklers, road dividers. That will reduce the burden of the fresh water. So 65 ml is used for gardens, fountain, and washing of the city. Our one plant, which is around 5 ml capacity, used. This treated water is used for different gardens within the city, and we have a plan for 40 ml capacity tertiary treatment plant, that is UF and UV, which will be commissioned in February 2020. So total reuse of wastewater is around 110 ml. So this is the service level benchmarking under MOUD Government of India, which is achieved by the NMMC. We have a coverage of toilet of 100% within the city. Sewer network is around 100%. We have efficiency of network is around 100%. So all this target is achieved. MOUD Government of India laid down to reuse the treated water to up to 20%, but in NMC area we use the we recycle and reuse of our current SLB is around 0.30%, so 35%. So extended realization of the customer is around 100%. There is cost recovery is around 100%. Sewerage charges is collection is around 100%. So all the target laid down by the MOUD Government of India achieved by the NMC. These are the different awards we got the NMC at the National Urban Water Awards in 2008. We have a Gadge Awards Nagar Suchita Abhiyan. We got the National Urban Award against in 2009. Best City Award under JNR in 2009. Vasundhara Award. Water Plus certification in 2021. Cleanest City in India awarded consideration from the last 4 years. So thank you very much. If you have any questions, so please let me know. Okay, madam. If you have any question,
Yes, sir. Thank you, sir. Sir, we got two questions from the
yes.
YouTube chat box. Um, 1 minute. First question is from the Professor Arjun Kadam. Sir, what are the future scope of drainage system in Mumbai?
What are the future scope of drainage system?
Of
Okay. Uh, for the drainage network in NMMC area, we have around 494 square kilometer of sewer network within the city. So around 99% of sewer network is there in within the city. We have only a 42 number of septic tanks which are yet not connected to the sewage network. But in the next 6 months, this septic tank is also connected to the sewer network. So again, in NMC area, there are different slum pockets like in Chinchpada, like it's Turve, like in Airoli. So we already started to let down the sewer network within the slum pocket. So after within next years, the sewer network within that slum pocket is also connected to existing network. So our target is to achieve the 100% sewage network for next 1 year.
okay. Okay, thank you, sir. Second question is from the student named Aryan.
Okay.
Sir, is there any upcoming water treatment plant set up for sewage process in Navi Mumbai?
So we have enough capacity sewage treatment plant. We have around 454 MLD capacity, which will cater the population of Navi Mumbai up to 2031. And the peak factor of this sewage treatment plant is around 2.25. That is total peak factor capacity of our 7 number of sewage treatment plant is around 960 MLD. And if we see the entire water demand for the Navi Mumbai is around 450 MLD. So out of that 450 MLD, that is drinking water requirement or that is demand for the city. Out of that, 80% sewage is generated, and within the sewage network, which is around 494 square kilometer, there is a distribution losses. So we got around 250 MLD raw sewage. So we have enough capacity of uh, our existing 7 number of sewage treatment plant. So is there any no planning for the new STPs? Because we already have enough capacity of STP that will cater the population up to 2031.
Okay, thank you. Thank you so much, sir. Um, Here our question answer session is end up, sir. Thank you, sir, for
Okay.
your valuable time and knowledge you are sharing with us.
Okay.
Participant, now I have end up here our day 3 session 1 of the STTP. Feedback form will be provided on your WhatsApp group, and our second session of day 3 is at 1:30 p.m. So join us sharp at 1:30 p.m. again. Thank you so much.
Thank you. Thank you very much, madam. चला